Hello everyone, this is Mr. William, and today's lesson is from Chapter 2, Lesson 1, Multiplicative Inverse. Multiplicative inverse. Our objective is I will be able to use the multiplicative inverse to solve one-step equations. Let's get started. What you need is your textbook, a pencil, and your note pages. Again, what you'll see in this video is where we work together. We do. Take notes. If I'm going too fast, you can pause to write your notes. You may have a quick write where you write and you talk to me or your partner about what you wrote. And number 3, you do means you work on your own and then you share that out with me or with a partner. So when we want to solve equations, we want to get the variable by itself. Well, here our variable is x. As we said before, get it by itself means I have a left side and I have a right side. I want to get the variable by itself. It doesn't matter what side it's on, but usually we stay on the same side. So getting the variable by itself means I want to get only one x over on one side by itself, because then what that means is this is going to be my solution and I will have solved it. So what do I do with the 2/3 to get only x by itself? And this is red. Let me back up. This is red. 2/3 times x equals 18. So it's a little bit different than what we've done before. We're multiplying, but it's a fraction. So you may say, well, is this multiplication or is division? Well, it's actually multiplication. All right. So before we answer that question, we have to know that we can turn any number into a 1 by using multiplication. So for example, 1/3 times some number gives me 1. What's that number? Well, 1/3 times 3 is the same as 1/3 times 3 divided by 1. So if you remember from multiplying fractions, we get 1 times 3 and 3 times 1, and we get 3 over 3, and that equals 1. So 1/3 times 3 is equal to 1. Well, the opposite of that is true. 3 divided by 1 times 1/3 is going to give me 3 divided by 3 gives me 1. So again, I can multiply and get any number, change any number to 1. So 3/5 times, what do you think? 5 divided by 3 gives me 15 divided by 15 gives me 1. Because it's 3 times 5 and 5 times 3 gives me 15 is 1. And the last one, 2/3 times, guess you got it, 3 divided by 2 gives me 2 times 3, 3 times 2, which gives me 6 divided by 6 equals 1. So I can multiply any number by another number and get 1. And we call that the multiplicative inverse because we are multiplying by the opposite. And let's think about it just as maybe as a flip. So if I flip the number over, I'm basically taking the inverse. So I'm gonna give you a little hint. We call that flip, meaning we're gonna turn the thing over. So I flip it over. So 3 is a multiplicative inverse of 1/3. Think about this. 3, 1. If I flip it, I get 1 over 3. So 1/3 is a multiplicative inverse of 3 because 1/3 times 3 gives me 1. Blank is a multiplicative inverse of 3/5. Well, if I take 3/5 and I just flip it over, I get 5/3. Okay? And just the inverse, 3/5 is the multiplicative inverse of 5/3. And the multiplicative inverse of 2/3 is 3/2. Okay? All right, so I want you to do this. I want you to tell me what the multiplicative inverse is of these, was it 5? Five numbers. Okay? So what do you think we need to do to get 1x by itself? We can get 1x by itself if we multiply both sides by, you got it, 3/2. So if I multiply, and I'll write it separately, if I take 2/3 x equals 18, then if I want to get 1x, I'll just multiply both sides by 3 divided by 2, 3 divided by 2, and again, it's like a balance. If I have 2/3 x equals 18, I must multiply both sides by 3/2 so that it still balances. So that's the multiplicative inverse, so it becomes 1x, which is what I want, and then this gives me 27. So that's my solution. Okay, so we want to get x by itself. If we have a coefficient that's a fraction, we multiply by the multiplicative inverse. So in your textbook, they tell you the multiplicative inverse or inverse property is the product of a number and its multiplicative inverse is 1. So if my number is 7/8, my multiplicative inverse is 8/7. I multiply them, I get 1. Here's your definition using symbols. Another way you can think of it is the multiplicative inverse is the number you multiply another number to get what? 1. Another name for multiplicative inverse is reciprocal. You may see reciprocal. Reciprocal. And the reciprocal of multiplicative inverse of 7/8 is 8 divided by 7. All right. So let's do a few together. So 1/5 times some number x is 12. How do I get x by itself? Well, I have to multiply both sides by the multiplicative inverse. So that's both sides by 5. This will cancel out. I have 1x left, and that's 60. This is my solution. What's the multiplicative inverse of 2/9? So it's negative 2/9 times some number d is equal to 4. So my multiplicative inverse is going to be negative 9 divided by 2. So I'm going to multiply both sides by negative 9 divided by 2, negative 9 divided by 2. This cancels out. I have 1d by itself, and that's going to give me a negative times a positive is negative, so I'm automatically know my answer is negative. It's going to give me a negative 18. Okay, so you might ask me, how do I get that? Well, 4 times negative 9 divided by 2 is the same as 4 divided by 1 times negative 9 divided by 2, which gives me a negative 36 divided by 2, which is a negative 18. Okay, we have 2 more problems here. I want you to go ahead and do those. Then we have 4 more problems here. I want you to go ahead and do those. Now here's one that's in the book, page 13. It's a little tricky, so I'm going to go over how to do this. So we have a fraction as our coefficient, and we have to find the multiplicative inverse. But one thing we must do before that is to change our mixed number to an improper fraction. Okay, it's in the book, so let's go over it. Okay, so my mixed number, meaning I have a whole number and a fraction, that's why it's called mixed. It has a whole number plus it has a fraction. So we call it a mixed number. Well, how do you do that? Well, what you do is you just go ahead and take your 6 and multiply by 4, and then you add 1. So we keep the same denominator. So it's 6 times 4 plus 1 gives us 25 divided by 6. That's a mixed number, improper fraction, and this is our improper fraction. I'm sorry, let's do it this way. So this is our improper fraction. Our multiplicative inverse is 6 divided by 25. So we multiply and we add. We keep the same denominator. So it's 3 times 3 plus 1 gives us 9, gives us 9 plus 1 divided by 3, which is 10 thirds. The multiplicative inverse, or the reciprocal, is 3 over 10. Here we have multiply and add, but you have to keep the negative sign. Keep the same denominator. 7 times 3 plus 4 gives me a negative 25 divided by 7. My multiplicative inverse is negative 7 divided by 23. So go ahead and practice these 3. Let me know what you come up with, and I'm going to go ahead and do this problem. So now they just add one step. We have to change our mixed numbers to improper fractions. And then we can solve. Okay, so what did we say this one was? This was 6 times 4 plus 1, which was 25, 6, equals 3 times 3 is 9 plus 1 is 10. 10 thirds times C. Then we're going to multiply by the multiplicative inverse, so we can get C by itself, which will give us 3 10, 3 tenths. So this and this cancel out. I have C by itself. So I'm going to come over here and do this. So I have 3 tenths times 25, 6. That gives me 3 times 25 divided by 10 times 6, which gives me 75 divided by 60, which if I simplify that, well, we'll leave it like that for right now. 75 divided by 60. But I can simplify that. I take 75 divided by 60. I'm going to divide that by 5. Divide that by 5. And I get, I believe, 15. And I get 12. But I can do that even, make that even smaller by dividing that by 3. And divide that by 3. And I get 5 fourths. So my solution is 5/4. 5/4 will make that true. And if you want me to prove that, I can. All right. Here are two more on page 113. You go ahead and do those two. Page 115, I want you to work on those. Now here, don't worry about this. Just because it's a decimal doesn't mean anything. I still have to divide both sides by that coefficient. And extra practice on page 117, take care of that. All right, so that's about time. Our objective was to be able to solve one-step equations using a multiplicative inverse. Here's your definition. Here's an example. Great job. Go ahead and do those problems and come talk to me when you want to get the answers and or ask me a question. Take care and talk to you soon.